Alrighty, good morning, Algebra 1 CP. We're about to get started with our very first video lesson here on solving equations. This is really the basis of everything we do in Algebra 1 CP, so it's particularly important that you watch this and ask any questions if you do have any questions. And if we're going to talk about solving equations, I think it's important that the very first thing we do is define what an equation is. So an equation is an expression that contains an equal sign. And you know that an equal sign looks like this. And that equal sign denotes, so I'd say which denotes that the value of the left-hand side is equivalent to, if I can spell, equivalent to the value of the right-hand side. So the classic example that's used all the time to illustrate this is like a scale. If you have equal things on either side, everything is perfectly balanced, correct? I'm usually a terrible drawer, but if I try to draw like a little scale here, picture a scale kind of like this, that's not that bad, right? And if I have equal quantities on this side and this side, then everything is perfectly balanced. And that's exactly what we want in an equation. We want everything to be perfectly in balance. And that's what an equation symbolizes, right? Consider then if we have something like this. So here's an example of equation, right? I can say that 3 is equal to 3. And I don't think anybody's going to argue that 3 has the same value as 3. Now, notice the left side, same as the right side. Now, equations can be changed in that you can modify the left side of the equation or the right side of the equation, but you have to be very careful if you do so. Say that I decide to add 1 to the right-hand side of the equation. Well, if you notice, this is no longer an equation as written here, because now you have 3 is equal to 3 plus 1, which is 4. But 3 is not the same as 4. That's not a proper equation. These are not balanced. So what can we do in order to balance that out? Well, if we are absolutely determined to add 1 to this right-hand side, we have to, in turn, add 1 to the left-hand side to now say that 4 is equal to 4. And we're back at that perfect equilibrium, that balance again. And that's absolutely true. We are allowed to add the same quantity to both sides of an equation, and it preserves that equality. If you took this side and added 5, and you took this side and added 5, you'd still preserve equality, right? Can you picture that? It'd still be the same. The same is true with subtraction. Say, for example, for whatever reason, I decided to subtract 7 from here. Well, I can't just do that on one side. We no longer have a true equation. We need to balance it out by doing the same thing on the other side, and that comes out to 4 minus 7, negative 3 is equal to negative 3. And once again, we're back to balanced. Back to balance. Do you see that? So I can subtract on one side as long as I subtract on the other side of the equation as well. And the same is true for multiplying and dividing, right? Suppose that I wanted to multiply and say I multiply by 10 on one side. Well, I have to multiply by 10 on the other side to preserve equality. That would give me negative 30 is equal to negative 30, which is still true. That's still a balanced equation, right? I can't just take this side and multiply by 10 and then do nothing here, because then you'd say negative 30 is equal to negative 3, and you'd be like, well, what the heck? That's not true. So it's important that whatever you do to one side, you have to do to the other side. Same thing is true with division. So multiplication, and I have to show off just the last one of division. So say I divided both sides by 6, for example. I now have negative 5 is equal to negative 5. We still preserve that equality as long as we perform the same operation on the left-hand side that we perform on the right-hand side, or vice versa. then that means your equality is preserved. Okay, does that make sense? Now, that may seem pretty obvious as just working with normal numbers, but what if we start to work with variables? And just as a reminder, a variable is a placeholder value that represents an unknown quantity. Okay? That's what a variable really is. It's a placeholder value that represents an unknown quantity. So, for example, I could have an equation like this, and I can say, well, x is equal to 5. Okay? That means that the value of x is 5, right, in this particular example. One common misconception that a lot of students have is just because an x is used in this problem doesn't mean that every single time you see the variable x, it's going to be 5. It just happens to be 5 in this case. If I add 1 to this side, I'd come up with x plus 1, but x plus 1 would no longer be equal to 5. Think about it. If this value of x is equal to 5, this x has a value of 5, then that means x plus 1 would have a value of 6. So we have to add 1 to both sides to preserve that equality. Does that make sense? If I want to preserve equality, suppose I want to multiply this side by 2 times 2, I get 12. I have to do the same thing to this side as well. I have to take the whole expression and multiply this by 2. And that would also preserve equality. It would also preserve equality, correct? Something you might recall is what's called the distributive property, where you could also rewrite this, if you so desire, as 2x plus 2 is equal to 12. Okay, because that 2 would multiply by the x and multiply by the 1. That makes sense? So equality is preserved. Notice, if x is 5, 2 times 5, if you plug in the 5 for x, would be 10, plus 2 would be 12. Everything is preserved. So, why is this important? Well, why this is important is because this exact logic can be used to solve equations for x. Here, we kind of started out where I told you that x was 5, so you were pretty easily able to follow everything along. But what if I don't tell you what x is, and I want you to figure it out? That's where we really get into the good stuff. All right? So let's start with something like this. Ready? A couple examples. Let's solve for x. Meaning that you're just trying to find out what variable makes this equation true. We'll start with it, which makes this equation true. We'll start with just a couple one-steppers, and then we'll do a two-step equation. Okay? So a one-step equation, x minus 3 is equal to 4. Okay? And you're trying to solve for x. What this means, I think it's very important to think about, like, logically, what is this actually asking? What this means is some number minus 3 is equal to 4, has the value of 4. So if you think about it logically, you may even be able to do it in your head, where you'd say some number minus 3 is 4. What number, if you take away 3, will get you to 4? Well, that's 7, correct? Because 7 minus 3 would make 4. If you can't do it in your head, though, you might be thinking, well, how the heck am I supposed to do that? You could take advantage of that fact that we just talked about, where you can add, subtract, multiply, or divide the same thing on both sides of an equation. Here, I would want to get the value of x alone, because the goal of this problem is to say x equals something, right? I want to solve for x. I want to find out what makes that true. So how can we get that value of x alone? Well, what I can do is right now it's sort of attached to this pesky minus 3 over here. Do you see that? This minus 3 is like clinging on to this x. So let's get rid of it. In order to get rid of the minus 3, or sort of undo the minus 3 so we can get just x, I can add 3 on this side of the equation, because you see that negative 3 plus 3 would be 0. And so you would just be left with x minus 0, which is just x, right? But hold your horses, just like we talked about before. I can't just add 3 on this side and call it a day. I have to also add 3 on this side, okay? Which means that now algebraically you would see that x is equal to 4 plus 3, which is 7. Does that make sense to everybody? hopefully. Let it sink in for a little bit. Think about, too, if, say, you had a one-step with multiplication. Ready? Let's solve. Let's switch up the letter a little bit. We'll solve for a. It doesn't matter what the letter is. Typically, it's x, but if it's solved for a, it shouldn't be like, oh, my gosh, it's a now, and I'm all confused. It's the same thing. If I'm trying to solve for a, say I have something like this. Negative 3 times a is equal to negative 6. Okay? Notice how I read that as well. The way I read that is exactly how you should think of it. You're thinking of negative 3 times some number. Remember, this is a little hidden sneaky multiplication in here. Negative 3 times something is equal to negative 6. So what is that missing something? What makes that true? Again, you may be able to do it in your head and say that, oh, well, negative 3 times 2 would be negative 6. But how do you actually get that result with algebra? Well, what I want to do is, again, I want to undo this operation here. If you notice, I have negative 3 times a. I don't want the a to be multiplied by negative 3. I just want the a to be by itself. So how can I undo this multiplication of negative 3? I can divide by negative 3. Because if you notice, addition and subtraction are inverses of each other. They undo each other. They're opposites. And multiplication and division undo each other. They're opposites. Okay? Because negative 3 divided by negative 3 is going to be 1. And 1 times a is just a. Likewise over here, I can't just divide by negative 3 on this side and ignore this side. I have to divide also by negative 3 to preserve that equality. And so I'm going to get that a is equal to 2. Remember, negative divided by negative makes positive. 6 divided by 3 is 2. Okie doke. And so you would find out that a is equal to 2. Any question about that? Hopefully it's sinking in a little bit. All right. Let's try a two-step equation now. Let's try a two-step equation. Ready? Let's solve for z. All right. Doesn't matter what the letter is. Could be anything. Let's do 2z minus 3 is equal to 11. 2z minus 3 is equal to 11. Again, you may be able to look at that and start thinking about it and do it in your head where you're thinking to yourself, 2 times some number minus 3 is going to give us 11. Right? So you might start thinking, you might start figuring it out in your head a little bit. 2 times something. You might be like, well, 2 times 5 is 10, minus 3 is 7. So it's not 5, but it's pretty close to 5 probably. But suppose you can't come up with it in your head, you could do it algebraically. And you could say, well, if 2z minus 3 is equal to 11, I want to get z by itself. Because I want to be able to say z is this. I want to be able to say, oh, the missing value for z is such and such. In order to do that, and before I can even tackle this term of 2z here, I need to get rid of this lingering minus 3. Right? Because before I even get to this, I need to get rid of anything else that's sort of attached to it down the line. So I'm going to do that by adding 3 to both sides. Okay? If I add 3 to both sides, that gives me that 2z. Notice the negative 3, positive 3 would be 0. 2z is now equal to 11 plus 3, 14. And now we've moved our two-step equation down to a one-step equation where we have 2z is equal to 14. I can divide both sides by 2, and we divide to undo the multiply, right, because those are opposites of each other. And 14 divided by 2 is 7. You would get that z is equal to 7. Okay? Something that you can do to double-check your work if you so desire is you can take this value and plug it back in for the variable and see if it works. Is it true that 2 times 7 minus 3 is 11? Is that true? And in this case, yes, it is definitely true. 2 times 7 is 14, minus 3 is 11. Any question about that? Let's do 2 more two-step equations, and then I'll point something out to you to end, and we'll be good to go. So another two-step equation. Ready? Let's solve. We'll go back to x, traditional. Solve for x. Okay. Let's do x divided by 4 plus 1 is equal to 6. Now you might look at that and you might be like, oh my goodness, there's a fraction. Holy cow. No reason to fret. No reason to panic. This is x divided by 4 plus 1 is equal to 6. Meaning, some number divided by 4, if you take that number, divide it by 4, and then add 1, you're going to get 6. So what's that number equal to? Might be, again, a little tough to do in your head, so let's try to do it one step at a time. First things first, before I can even approach this thing with the variable in it, before I can even get to this term, I need to get rid of all of the other stuff that's attached to it. So what I'm going to do is I'm going to subtract 1 from both sides. And the reason why, hopefully you're understanding why I'm subtracting 1 from both sides, is because I want to get rid of the plus 1, because it's in the way of getting to the x equals. In order to get rid of it, we need to do the opposite of plus 1, which is minus 1, because 1 minus 1 goes away. 6 minus 1 now on the right side is going to be 5. So I get x divided by 4 is equal to 5. Now, think about this. I have some number divided by 4 is 5. How can I get rid of this division by 4? What should I do to both sides of the equation to undo division? Well, what I can do is I can multiply by 4 on both sides. Because if you take a number and divide it by 4 and then multiply it by 4, you'll just get back where you started. This undoes itself, right? I'm left now with x equals, and 5 times 4 is 20. Okay? Does that make sense to everybody why that's the case? Notice you can go ahead and take this number, plug it back in, and it should check out. 20 divided by 4 plus 1. 20 divided by 4 is 5, plus 1 is 6. Bam, works out just fine. And I encourage you to do that too. If you're ever confused as to whether or not you got the right answer, you can always go back and check your work. Alrighty? Questions, comments, concerns about that? Okay, let's do one more two-step equation, and then I'll call attention to something that I've been doing kind of sneaky along the way, and then we'll go from there. Okay? Let's see. How about negative 3 minus 2x is equal to, let's say negative 1. Okay, negative 1. Well, how would I solve this? Again, I would love to attack this x right here, right? But right now, I can't get to that because there's this negative 3 lingering on the outside over here, right? It's lingering on the left side. I don't want to do negative 3 minus 2x. I want just x. So first I'm going to get rid of the negative 3. Anything that doesn't have a variable in it, any term, any piece that does not have a variable in it, let's get rid of that and move it to the other side. Notice I can't just add 3 on this side. I have to do it on this side as well. Gives me negative 2x is equal to negative 1 plus 3 is 2. Now, what do? I have negative 2 times x is equal to 2. Think about it. It's asking you negative 2 times some number is equal to 2. We can divide both sides by negative 2 to undo the multiply by negative 2. Right? Multiplying by negative 2, dividing by negative 2 cancels out. I'm left with x equals 2 divided by negative 2. Positive divided by negative is negative. 2 divided by 2 is 1. And so you get a solution of x equals negative 1. Okie doke. Notice you could always go back and check your work. Take the negative 1, plug it in. Negative 2 times negative 1 is positive 2. Minus 3 is negative 1. Notice the order of operations, right? I did the multiply first, and then add the negative 3. Bam, we get negative 1. Okay? One thing that I've secretly been doing, and one thing that I encourage you to do, is notice that I'm writing out each step, and I'm also writing what I'm doing to both sides of the equal sign. I highly recommend doing that. Highly, highly recommend. If you have, an equation like this, let's say 13. It's very important, I think, especially to avoid being confused. It's very important to take it one step at a time and say, well, in order to tackle this, I first need to get rid of the plus 1. I'm going to do that by subtracting 1. This cancels out. I get negative 3x is equal to 13 minus 1 is 12. Now I divide both sides by -3. You get x is equal to -4. This cancels out. Notice that I'm keeping this like equal sign sort of as the barrier between the left side and the right side. And that's exactly what's true. This equal sign is like a wall. Things can't pass this wall. I don't want to see anybody like doing like in this example here, x divided by 4 plus 1 equals 6. We don't add the 1 and the 6. They're on opposite sides of the equal sign, right? This is your barrier. This is your wall, right? In order to get rid of something over here, you have to do the equivalent operation over here. Does that make sense? And then, by the way, you could always go back, take these values, plug them in, and see what you get. Take -4, and it should check out. -4 goes back in for x. -3 times -4 is +12, plus 1 is 13. Alrighty. So hopefully that does a pretty good job of explaining 1- and 2-step equations. If you do have any questions, please feel free to let me know via email. As you can see in my little layout here, I don't have a webcam yet, but I'm hopefully going to be bringing it into school soon, so we should get that all hooked up. Let's see, anything else I want to add? There are a couple practice problems that are going along with this video. If you could please complete those, that would be very, very helpful, both for you and for me, to make sure you're doing your work and you're understanding this idea. Next class, we're going to take a look at what if there's more than 2 steps? What if we do 3 steps or even 4 steps? What does that look like, and how is that gonna function? All right. So I hope you have a great rest of your day. Thank you so much for your attention and focus, and I will see you next time.